Here we go. We got a new and probably not improved Zoom. So we're going to see how well this works. This is our Unit 2 test review. All right, so this thing a little bit long, so just kind of bear with me. Every single video I make is going to be a different page. So the first video, page 1, second video, page 2, page 3, and so on and so forth here. All right, so let's just jump right into it. For each statement, underline the hypothesis, circle the conclusion, state the converse, state the inverse, be contrapositive, and tell the truth value of each statement. There's a lot going on. I'm going to type all of those out, all right? So let's see here. First things first, underline the hypothesis. So M is between A and B, and AM equals MB. All right, so the hypothesis is always everything between the if and the then, right? So we have our notation is P arrow Q. That is our conditional statements. So if P, so in this case, if M is a midpoint between A and B, if M is between A and B and AM equals MB, that is the hypothesis. Now, the conclusion is M is the midpoint of AB. Is that a true statement? Well, yes, it is. All right, so I'm going to put a T on that one. All right, now they want us to write out all of the following. So let's go ahead and do that. I'm going to type all of these out because that is a lot to write, and I don't want to do that. So let's see here. The converse. So remember, the converse is you just switch the order. So I'm going to say if M is the midpoint of AB, then M is between A and B, and AM equals MB. Right? That's your converse. The inverse. The inverse is where you keep the same order as the original, but you negate both of them. All right, so what is this one going to look like? I'm going to say if M is between A and B, and AM is not equal to MB, then M is not the midpoint, of AB. That one's done. The contrapositive. That one says if M is not the midpoint of AB, then M is between A and B, and AM is not equal to MB. All right. So there are kind of the three different ways that we can write these things. All right. So now in this first one, the converse. If M is the midpoint of AB, then M is between AB, and I would agree with that. I'd say that is a true statement. Now the next one. If M is between A and B, but AM is not equal to MB, then M is not the midpoint of AB. Again, that seems true to me. All right. And the contrapositive. If M is not the midpoint of AB, then M is between A and B, and AM is not equal to MB. Let's see here. If M is not the midpoint of AB, then M is, all right, so this one, I'm going to say true. You could argue that this one is false because there's kind of two things going on here. I'm going to assume that M is between A and B still. All right, I'm going to assume that that is kind of part of the condition that needs to be met here. All right, so that is number one. So again, the original conditional is P arrow Q. The converse is Q arrow P. The inverse is where you keep the same order, not P, arrow, not Q. All right, and these are always of the original statement. And the last one, the contrapositive, you flip them both, you negate them both. All right, so not Q implies not P. All right, 3 and 4 provide a counterexample to disprove each statement. All right, so basically what they're saying is 3 and 4, these are false statements. In order for a counterexample to exist, it has to be false. So let's see here. If A is less than 100, then A is an acute angle. That's definitely false. I'm going to say A angle A is equal to 99 degrees. All right, so that counterexample, the first part remains true. All right, A is less than 100 degrees. That's true. All right, 99 definitely less than 100. However, 99 is not an acute angle. All right, remember, acute angles are anything less than 90. So whenever we're providing counterexamples, try to keep that first part true, but you want to make the second part false. All right. On the next one, if x squared equals 36, then x equals 6. All right, I disagree with that one. So x squared equals 6. There's a couple ways we can solve this, but the easiest way I see is to cancel out the square. A square root will kill a square. So we're going to say x equals, and this is the part that we have to be careful of. This is the part that a lot of people forget. The plus or minus 6. All right. Therefore, this literally means x equals 6 or x equals negative 6. All right, so that counterexample is negative 6. All right, now another way to think about this one. If we wanted to factor this, I'm going to say x squared minus 36 equals 0. All right, this is a difference of squares. So we want two numbers that multiply to x squared. I'm sorry, two things that multiply to an x squared. That's going to be x and x. And then two numbers that multiply to 36. However, there's no middle term here. So if you wanted to, you could almost think of this as x squared plus 0, x minus 36 equals 0. All right, so we want to multiply to a 36 and add to a 0. And the only way to do that is having a negative 6 and a positive 6. Right, now we set each factor equal to 0. We're going to say x minus 6 equals 0 and x equals 6. Then on the next one, x plus 6 equals 0. Therefore, x equals negative 6. All right, so I think the second way is kind of a better demonstration of why we do have those two answers. Whereas this first way, if you forget the plus or minus, or a lot of times we think, why do we add that plus or minus there? That's kind of the reason why. So our counter example for this problem is, well, x equals negative 6. Right? And again, we're keeping the first half true. Negative 6 squared is positive 36. Negative 6 squared does equal 36. All right, but x is not 6 in that case, right? Because 6 is not equal to negative 6. All right, so keeping the first half true, the second half false. All right, a couple more here. Justify each statement with a property of equality or congruence, right? So these are congruent symbols in here, so this is going to be a congruence kind of theorem. If angle 1 equals angle 2 equals angle 3, then 1 equals 3. All right, I like to call this one the leapfrog property. Angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So what I'm going to do is I'm going to leapfrog right over angle 2, and I'm just going to go straight for the kill here. And I'm going to say angle 1 is congruent to angle 3. This is what we call the transitive property. All right, this is technically the property of congruence because we have congruent symbols there. All right, this next one, RQ equals RQ. Anything is equal to itself. This one is the reflexive property. This one I kind of think of as like reflection. Think of a mirror. All right, so anything equals itself. Which that's a silly kind of idea, but hopefully that does make sense here. So RQ is equal to RQ. That is the reflexive property. All right. Now the next one here, they're saying if x plus y equals 7 and y equals z, then x plus z equals 7. What they are doing is they are substituting out this y with the z. All right. So basically here, I'm going to write these two vertically. X plus y equals 7. And then we have x plus z equals 7. All right. We know since y and z are the same thing, all we're doing is we're just switching those out. All right. Y equals z. All right. We're just using the substitution property. And that's a very, very useful property to use in geometry here. All right. Now, this next one. They are saying if angle 1 equals angle 5, then angle 5 equals angle 1. This is the symmetric property. Basically, what they're saying is it doesn't matter what order you write them. So I could say x equals y is the same thing as saying y equals x. Or I could say 2 plus 3 is the same thing as saying 3 plus 2. If something has the symmetric property, it doesn't matter what order you write them. That's essentially what it says. All right. And the last one here. Okay, this is the addition property. All right. So basically, we're starting out with angle 1 equals angle 2. All right. Well, that's what they're giving us. And then they're saying, all right, well, angle 1 plus angle 3 equals angle 2 plus angle 3. So here's what we have. I'm going to kind of start with something. I'm going to start with an angle 3. Angle 3 equals angle 3. That is the reflexive property. All right. So since angle 1 and angle 2 are the same thing, let's kind of think of it like this. I am going to say, all right, angle 1, I'm going to add an angle 1 onto both sides. I am adding equal amounts onto both sides of this equation. It's still balanced, all right? But since angle 1 and angle 2 are equal, what I'm going to do is I'm going to go ahead and swap this out with an angle 2. Since angle 1 and angle 2 are the same thing, I can rewrite this as angle 1 plus angle 3 equals angle 3 plus angle 2. And that's all there is on that one. So that is the addition property of equality. We are adding equal amounts to both sides of an equation here. All right. So that is page 1 of your test review, and we will see you guys in the next one. Now I got to figure out how to stop these recordings because Zoom is updating, and you guys can just awkwardly hear me talk for a second while I figure this out.